Today's problem is going to be the longest substring without repeating characters. Given a string s, find the length of the longest substring without duplicate characters. A substring is a contiguous sequence of characters within a string. Of course, if we have the string s, right, we can substring this in a lot of different ways. No matter how we slice it up, it seems that the longest substring without any duplicates is 3 elements long. It could be this, it could be this, it could be this, or this. We do have a lot of options here, but as soon as we try to go to 4, it stops working, right? It has to be contiguous. None of these work. And if we try to go smaller, that's also okay, but that wouldn't be our best answer, right? And looking at this one, of course, when you have a string that's all single characters, the longest substring that we have without duplicate characters is just 1 element long. So we can figure this out. All we have to do is keep a sliding window of our substrings. Say this is our input string s. Now I want to keep a window of all the valid subarrays, and valid means that it contains no duplicate. If I'm able to check every single valid subarray, then I can get all of their lengths and take the best one to return. So first I'm going to instantiate my left and right pointers on the very first index, and this represents my current window. My window is 1 element long and only contains the letter z. It starts at index L and ends at index R. So let's observe. At this point in time, if I were to keep track, our best answer is going to be 1 element long, right? We have a single element, and this substring contains no duplicate elements. Now, I'm going to get greedy, and I'm going to expand our window. I want to expand our window to 2 elements, right? So it's going to start at L, and it's going to end at R, like so. So far, pre-expansion, we've only seen a Z, right? And when we encounter this new element, it seems that it's not a duplicate, right? We haven't seen it before. So okay, now we've seen X. The size is going to be 2 elements long. So because X is not a duplicate, that it means that our substring is valid. So since it's valid, let's just take the length. The length of this is 2, and 2 is greater than 1, and our best score will be updated to 2. All right, next element. I'm going to get greedy once again, and I'm going to expand our sublist to 3 elements. Now this is where it gets interesting here. We encounter another X. Unfortunately, we have seen this X before, so that means this is a duplicate, right? ZXX is not a valid substring, and thus we can't consider its length. So what do we do? Well, looking at this, there's no point growing this anymore, right? No matter how far we grow this, because we found a duplicate here, if we were to continue expanding beyond that, it will be pointless because all of these substrings are not eligible. We have to shrink our sublist until such a time where it is a valid substring once again. So okay, how do we shrink this? Well, we shrink it by moving the left pointer. So I'm going to continuously wipe out each element until such a time where our substring is considered unique. So I'm going to wipe out Z. I'm going to get rid of U from our substring, right? And because I've gotten rid of it, I'm going to remove it from our scene as well. So then we check once again, is XX a valid substring? Well, clearly not. Removing Z didn't solve the problem. We needed to remove X as well. So okay, we remove X. And now it's just a single element and we haven't seen anything. Okay, now a single X, this is a valid substring, and then we can add this X value into our scene and take the length of this, which is 1. Unfortunately, that doesn't update our best score. Now the reason why we're throwing away Z, even though Z's not the problem child here, is because we want a substring, right? And substrings are contiguous. We need to toss out everything so that we have the space to explore further. So let's move on. So in the next iteration, I'm going to move R here as well. So this will be 2 elements long, and then our substring is XY. Y is not an element we've seen before, so we can add that in. And since it's valid, we can take the length and compare it to our best. It's the same, so nothing happens. Okay, next iteration. We get greedy, and then we expand yet again. We find an X. We have seen an X, so XYX is not valid. We need to start shrinking. Shrink, shrink, shrink until we have a valid substring. We shrink this, now it becomes YX, we remove the X from the scene, and then now this is valid, right? It's valid, so I can add our X to the scene, do the usual, take the length the same, nothing happens. And then it's just rinse and repeat, right? Next is XYZ, we move R here, Z is a new element, so we can add that to the scene, it's valid, we take the length, 3 is greater than the best, so we'll update our best to 3. And you get the point. This example is a bit long, so I'm just going to delete the rest of this and just say that we finished. Before we jump into the coding section, I'll say that this is a really common pattern for sliding window style questions, where you try to grow your window as large as possible, and then as soon as it's not valid anymore, you start shrinking it from the left until such a time that it's valid, and then you start growing it again. And typically with these kinds of problems, you're dealing with like finding some sort of contiguous block. All right, let's jump into the coding section. Okay, so we're going to start off by defining L and R, which is going to be the start and our endpoint of our sliding window. And then we're going to keep track of a variable called longest. This is going to keep track of the longest valid substring that we have so far. And then I'm going to need to create a set. And this is just going to store the values that we've seen, right? And just for reference, I'm going to say this is going to be our sample input, so we can refer to it as we go along. Okay, so first of all, we need a while loop. Our R is just going to be moving one element at a time, chugging along until the very end. And then eventually, after we fill out this loop, it's going to update the longest here, which we'll just return at the end. Now, what actually goes on in here? So the first element here is Z, right? We've not seen Z before. It's actually a new element. So we do know that if we encounter a duplicate element at R, we need to start removing elements from our window, right? We'll worry about that later. This is a non-duplicate element that we've seen. So we'll have to add it to our little set here. And then we need to calculate the length of our substring, which is going to be R minus L plus 1. And then we need to update our longest, right? So things are pretty straightforward if we find a non-duplicate character. So let's go to the next element here. We have ZX now, right? So our window is ZX. X is a new character. So we just add it and yada, 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 update the length and stuff, right? And what about the X after that? When we encounter this X here, this is going to execute, right? Because R is going to be pointing at this new X character here, and this X is already in scene. So what do? We need to start shrinking our window. We need to get rid of this Z, right? So we need to remove it from the scene set. So we're going to get rid of it in scene. And then by moving this window, we're basically getting rid of Z. Well, it's still a problem. We still have a duplicate. So we're going to shrink it one more time, get rid of this X, move the L pointer, and then now our window is just left with the character X, which we will add here, take the length, so on and so forth, right? And this is pretty much all we need. Let me just run the code real quick. And there you go. As for the time complexity, well, we know that R is going to go through every element one time. And we also know that L, in the worst case, is going to go through each element once, right? You can imagine that if my input, like the beginning, was all single characters, R is going to go through each element once. Every time we encounter a new X, we have to shrink our window, and then we'll expand it, and then we'll shrink again, and then expand it, and shrink again. And each shrinkage means that we're moving L by 1 unit, right? So R is going to move n times, and L is going to move at most n times, right? So just by the virtue of moving the pointers, our time complexity is O of 2n, right? And what else is going on here? Removing from a set is O of 1, adding to a set is O of 1, and then the rest of these are O of 1 operations. So not much to say here. The total time complexity is linear. And as for the space complexity, we do have a set, and in the worst case where every element is a unique character, then the set is going to be equal to the size of the input. So our space complexity is also linear, and that's about it. Thanks for watching. Okay, bye.